the different solventing extraction. So solventing extraction use triphosphate, triacylphosphate, and thiazolidine. So cationic extractions. So these are used in copper, zinc, nickel, cobalt, and silver. Anionic exchange, the solvent used are primary amine, secondary amine, tertiary. These are the used for separation of uranium, thorium, vanadium, and cobalt. In chelatic extraction, these are used the solvent. These are applied for the separation of copper, nickel, and cobalt. So, two basic steps in solvent extraction. One is extraction and in the stripping. So listen, this is uranium compounds used in this solvent. So we'll get a complex type of compound, and this complex type of compound again reacts with sodium carbonate and base-like substance. So this base will remove the amine parts to from this extraction. So in the next step, we'll have a uranium complex here solvent extraction. So these are the industrial process of solvent extraction of uranium here. And then so what are the distribution coefficient in the solvent extraction at a certain temperature? The ratio of concentration of solute in each of the solvent is always a concern. This ratio is known as the distribution coefficient. So what is the distribution coefficient? Concentration of metal ion in organic phase divided by concentration of metal in the aqueous phase. So this is the distribution coefficient. So concentration of metal in organic phase, concentration of metal in aqueous phase. So this ratio is known as distribution coefficient. Distribution coefficient. Solution solvent in organic phase, solvent in aqueous phase. So this will be two phases will be there in solvent extraction. So the ratio is known as distribution coefficient. So organic phase, this organic liquid will insert with the water, and these are the mechanism of solvent extraction. So these are the for physical kinetic study of extraction equilibrium. So all the extracted molecule will remain in this equilibrium. So listen, this is ion reacts with organic solvent to form this complex. So the extraction constant or equilibrium constant will be like this. Next extraction constant can be expressed as this expression coefficients. So logarithm of both sides will get this equation like equilibrium constant. So extraction coefficient it indicates how much the metal will move from aqueous phase to organic phase in a single contact. Effective extraction coefficient can be expressed as organic phase, the concentration of ion in organic phase, volume of organic solvent, and ion present in a concentration of ion present in aqueous solution and multiply by volume of aqueous solution. So single state versus multiple. So these are the separating funnel. So separating funnel here, the lower part is organic compounds in aqueous layer and another is solvent layer. So organic compound in solvent and this is aqueous layer in the extraction. So after before extraction, this is after extraction. So after extraction, we will get organic compound in the solvent layer. The organic compound in aqueous layer will come in the before state. Single state process is commonly followed by laboratory step. Contracting carried out by taking two phases together in a separating funnel followed by vigorous agitation so that phase may disappear. So these are the different solvent extraction phenomena where X0 concentration of metal ion in the free solution, aqueous phase before any contact. H1 concentration of metal ion in aqueous rapid. So from mass balance it can be shown that X0 by X1 is equal to 1 plus X0 concentration of metal ion in the free solution. So multi-stage counter current, single electron system. So these are the different equations where we get different. So selection of different organic solvents, high extraction capacity, selectivity, easily stripped immiscible aqueous phase, low viscosity, non-toxic solvents. So we'll go to the actual. So in unit 1, this is the general aspects. So in separation, we use especially chromatography, which is the main part of this unit. So what is chromatography? So the twist use chromatography to separate flank pigments in 1906. Colorful separation of plant pigment was done using by column calcium carbonate chalk. A new technique was called chromatography because the result of analysis of written in color. So color was chroma. So chroma means color. So this is the technique chromatography is a technique used to separate and identify the components of a mixture. Principle works by allowing the molecules present in a mixture to distribute themselves between a stationary and a mobile medium. Molecules that spend most of their time in the mobile phase are carried along the phase. So here in a chromatography we have a mobile phase, stationary phase and supporting heads medium. So basic terms used in chromatography: absorption, interaction of solute molecules with the surface of the stationary phase, eluent the mobile phase, illusion motion of the mobile phase through the stationary phase. Illusion time, the time taken for a solution to pass through a system. So that is illusion side. So absorption, elutant, mobile phase, illusion, motion of mobile phase, illusion time, the time taken for the chromatography, stationary the part of chromatography system that is. So these are the terminology used in chromatography. So normal phase, reverse phase, resolution, RF value, what is RF value, distance traveled by a solute, distance traveled by a solvent. So this is RF value, and these are the terms used in the chromatography. So what are the classification of chromatography? On the basis of interaction of solute with the stationary phase, on the basis of chromatographic bed shape technique by physical state. So let's see the classification on the basis of interaction of solute to stationary phase. It is divided into adsorption chromatography, partition chromatography, ion exchange chromatography, and molecular chromatography. So listen, on the basis of chromatography grade on which chromatography is observed: column chromatography, thin layer chromatography, paper chromatography. So technique by physical state of mobile phase. On the basis of technique by physical state, it is divided into four types: gas chromatography, liquid chromatography, affinity, and supercritical fluid chromatography. So these are the different classification of chromatography. So let's see one by one. First is absorption chromatography. So absorption what is absorption chromatography? utilize a mobile liquid or a gaseous phase that is absorbed on the surface of a stationary solid phase. Stationary phase adsorbent filled in a tube column. Mobile phase various solvent elutant is used. So these are the basic principle of adsorption. On the oldest type, solute molecule. This is one of the oldest type of chromatography. Solute molecules bond directly to surface of stationary phase. So partition chromatography. The partition component of a sample between a sample and liquid gas stationary phase heat at some components sample more as compared to others. So these are the basic principle of partition. So first we have seen that absorption chromatography and second one is partition chromatography based on the thin film formed on the basis of surface of a solid support by liquid stationary phase, solute equilibrium between mobile. So ion exchange chromatography. So in ion exchange chromatography, we will see the separate section for this chromatography. First of all, we'll see different chromatography in a short content. So resin stationary phase used in a covalent attach anions, cations onto it. Solute ions of the opposite charge of the mobile liquid phase are attracted to the resin by electrostatic force. So in ion exchange mechanism, one ion will attract to another. So here you can see we have a positive charge and negative charge in the ion exchange chromatographer. Mobile anions held near cation that are covalently attached to system. So column chromatography, simple column. In column chromatography, we have a column. We have different mixtures we load in a column. So one by one compound will elute from other. So you can see stationary phase held in a arrow in a column. So different one first red will come, then green will come, then at least or a red or another compound will come. So in this column chromatography, we can separate mixture of compounds one by one. So let's see factors affecting solute separating column. So factors particle size of solid stationary phase, decrease of size improves separation, column dimension efficiency increase the ratio length width, uniformity of packing, column temperature, eluting solvent, solvent flow. So these are the factors which affect the column chromatography. Means particle size, solid stationary, column का dimension, packing uniform. The packing should be uniform. Column temperature should be maintained. Eluting what solvent will be taken. Solvent flow rate that can be flow low or uniform or fast. Continuity of flow. Flowing should be continuous. Condition of adsorbent. What adsorbent will be taken to this connection of solutes. So, illusion technique, isocratic illusion, addition of solvent mixture fixed command during the work, gradient illusion, continuous linear illusion only. So these are different illusion technique using. So now we'll see most popular paper chromatography. So listen, in a paper chromatography, one jar will be taken. In the jar, the different spots will be given, mixture of solvent will be given in the paper. So this due to the flow of solvent in the mixture will separate in different color. So you can see use a filter paper strips as a carried or inert support. The factors governing separation of so due to the partition of two immiscible phase, we can see the color. You can see the paper. In the paper in the lower part, we have given a mixture spots. So when solvent will flow and capillarize, these spots will separate. We'll see in different slide. A small dot or line of sample solution placed into a strip of chromatography paper. Dot or line of sample solution. The paper is placed in a jar containing a shallow layer of solvent and sealed. As the solvent rises through a paper, it emits the sample mixture which starts to travel up the paper with the solvent. This paper is made of cellulose. तो पेपर को कहते हैं सेल्यूलेज रहती है a polar solvent and the compounds within the mixture travel further if they are non-polar. So next thin layer point. So TLC is simple like paper, but it is a small thin layer chromatography paper. So this is a jar. So we will in this jar we take a thin layer chromatography TLC plate, and here we will be given solvent, and the solvent will capillarize on the thin layer. So we have a stationary phase of thin layer adsorbent here. Solution, we can see this is a thin layer. We can give a different spots here. Aqueous solvent will flow and that will capillarize. We will get different stuffs. Solution. So these are the basic concept of chromatography. We'll see one by one. So let's see. So first we'll start from gas chromatography. So what is gas chromatography? This is one of the technique of separation of mixtures in chromatography constant. So gas chromatography is a process of separating components from the given crude drug by using a gaseous mobile. So you will use a gaseous mobile phase here. It involves a sample being vaporized and injected on the head of chromatography column. The sample is transported through a column by flow of gases. So here inert gaseous mobile phase will be taken as gaseous phase. So you can see on the slide what are the different phases we taken. So gas chromatography is one of the widely used chromatography technique which use inert gas as the mobile gas. Okay, so we use inert gas as the mobile phase in gas chromatography. In gas chromatography, the components of sample after vaporization are separated by being partitioned between gaseous mobile phase and liquid state. The inert gas doesn't interfere with the analyte by transporting the components through the column. So these are the introduction of gas chromatography. The principle of separation in gas chromatography is a partition. The mixture of components to be separated is converted to vapor. So these are the principles of gas chromatography. The principle of separating gas quantity. The mixture of component to be separated is converted to vapor and mixed with the gaseous mode. The components which is more soluble in stationary phase travels slower and diluted later. The component which is more soluble in stationary phase travels slower. So it will travel slower and that obviously eluted by river later. The component which is less soluble in stationary phase travels faster and that will be eluted out faster. So no two components are the same partition coefficient condition. So the components are separated according to their partition coefficient. So partition coefficient is the ratio of solubility of substance distributed between two immiscible liquids. So gas chromatography requires a mobile phase and a stationary phase. So all other chromatography Like all the chromatography, it should have a mobile phase and a stationary. So mobile phase is comprised of an inert gas, which can be helium, argon, or nitrogen. The stationary phase consists of a packed column. So stationary the mobile phase control inert gas that can be helium, that can be argon, that can be nitrogen, that can be xenon, whatever. In a stationary phase, it could be packed column in which the packing of solid support or liquid core act as a stationary. The main principles involved are absorption, partition for a gas-solid chromatography, and gas-liquid chromatography. In a gas-solid chromatography, the analyte of a mixture distribute themselves between the gas phase and adsorption. The difference in the adsorption behavior causes separation, where in a gas-liquid chromatography, partition coefficient is the main factor for this. The analyte of a mixture distributed themselves between gas phase and liquid phase according to their partition coefficient. The separation of compounds is based on the different strength of interaction of compound with the system. The stronger the interaction is, the longer the compound interact with the system, and the more time it takes to migrate through the column. The separation of analyte depends upon the method. So, what are the phases used in gas? First, we'll discuss a mobile phase. So, in mobile phase, as you know, we can use a inert gas. So, this inert gas can be used as a carrier gas. So, mobile phase means that is carrier. Mobile phase involved in the gas chromatography J gas. As the gas is used to transport a sample component through a column, so that's why this is called a carrier gas. So carrier gas are compressible gases that expand with increasing temperature. This results in a change in the gas resource. The selection linear velocity of carrier gas will affect the resolution and retention times. So carrier gas are hydrogen, helium, argon, nitrogen, etc. So this is all about the mobile. An ideal carrier gas should meet the following requirements. A carrier gas should be enough so that it will not react with a mixed structure. So as the inert gas, noble gases can react faster as other gases. So that will be used as a carrier gas. Sample to be analyzed. It should be comfortable with a detector and it should be easily available and not much expensive. It should be highly pure, 99%, no impurities will be there. It should be easy for handling in terms of fire hazard. It should be contribute mainly to the partitioning process. So these are the different conditions for a ideal gas. Carrier gas. So carrier gas are hydrogen, helium, nitrogen, and argon. So these are the mostly used carrier gas. It is better thermal conductivity, low density, suitable for thermal conductivity detector and ionization, etc. Helium, it has got a excellent thermal conductivity, low density. Inert gas allows greater flow rate, suitable with thermal conductivity. This is inexpensive compared to helium used in tanks. So these are the gases used in carrier as carrier gas in gas compound. Carrier gases are usually stored in a cylinder in compressed form. Another opinion is gas generator produce gases continuously. Filters, dried and observing tubes are used to remove the moisture. The gas flow rate is cylinder controlled. Next, what about the stationary phase? Stationary phase, gas solid chromatography and gas liquid chromatography. In the both cases, we are discussing about stationary. stationary phase. In a gas solid chromatography, stationary phases are solid absorber. Analyze the adsorb on the surface of solid. Different types of adsorbent are used in gas liquid chromatography. In a gas liquid chromatography, stationary phase is liquid. So here, gas solid and gas liquid. So we know mobile phase is a gas. So gas solid stationary will be solid. In gas liquid stationary phase will be. So these are the different stationary phase used for different gas. So let's discuss type of gas chromatography. Gas liquid chromatography. The principle involved in gas liquid chromatography. The components of sample to be analyzed in partition between the inert gas, a liquid phase which coated on a solid. Gas solid chromatography. In this technique, stationary phase is solid absorber. Principle involved in gas solid chromatography is the absorber. So these are the different conditions for gas liquid and gas solid chromatography. So what are the instrumentation? How this gas chromatography is designed? What are the different instrument arrangement in a process? So first we'll take this is a carrier gas will be filled in this cylinder and this will flow control will be there. Here we can inject the sample. So here sample injector. So here is the carrier gas. The flow can be controlled here. Sample can be injected here. So this is the column is given here. So from sample injector, column is a coil. So this is a thermostatic oven will be there. And here detector. And detector will detect the compound here. So in this way, waste will be from the system. Okay. So you know carrier gas can carry very well-known instrumentation of gas chromatography. So your cylinder will be given, gas to control will be given, and you can inject the sample from injection port. By using detector, you can see all the spectrum separation of different compounds. So carrier gas cylinder gas tank is filtered with a pressure control. Control the pressure of a gas, a pressure gauge that indicates the pressure, a molecular sheet transform it to meet the color. So these are the different. So a carrier gas is a chemical inert. It can be cheap, readily available, high quality, not cause any fire accident. That carrier gas is the best possible result can give. So these are the different characteristics of carrier gas. So listen, carrier gas can be carried out in a cylinder, hydrogen cylinder, argon cylinder like this. So this is a high pressure, inlet pressure is the most preferred gas. Helium pressure is high pressure will be given to this. High pressure will be given to flow rate should be more. This is sampling. So this is a micro syringe. So micro syringe will be given sample unit by injection. So in the inject point, this micro syringe is used for injection. So since the sample should be vaporized, and port is provided with a oven that helps to maintain temperature. So by using this micro syringe, we can inject some split injection. So injection when we inject capillary column will separate a split vent. So this capillary splitless injector. It splits the volume of sample stream into two unequal flows by means of a needle valve, allow the smaller flow to pass on the column. Splitless injector, they allow all the sample to pass through a column for loading on column series with a vent. These are the different conditions. Injection of sample into capillary. Automatic injector, we can automatically inject the sample. So column units. So come to column unit. Columns are different size that includes tube type, coiled helix type. So these are a different type of column unit. Aluminum, gas, nylon, others synthetic. Main function to provide mechanical support to the electrode. So liquid, it should have the following required. So liquid, gas, liquid phase should be a non-volatile liquid, should have high decomposition temperature, should be chemically inert, should possess a low vapor pressure at column, should chemically and structurally similar. Example of different liquid phase. So what are the liquids will be given? Non-polar hydrocarbon phase, paraffin oil, silicon oil, silicon rubber. These can be used as a non-polar hydrocarbon. Polar compounds, which polar polyglycols can be given for the polar liquid having hydrogen bonding, glycol, glycerol, hydroxyl. So example of different. So what are the types of columns will be taken in gas liquid chromatography? Packed columns. They are densely packed with fine divided inert solid support. In GSC, the columns are packed with length 1.5 internal diameter this millimeter. So these are packed columns. Wall coated columns consist of capillary tube, support coated columns. Porous layer, tubular column, and packed capillary column. Wall coated open tube. So these are the different column size depending upon the pore size. We can see different columns are used in the different gas columns. Equilibrium of column. The packed columns are equilibrium before introduction of the sample. This is done in allowing continuous flow of heated carrier gas. So column temperature. The compounds of low melting point eluted at lower temperature. Compounds with higher boiling point at the higher. So we should maintain the column temperature depending upon the mixture. Detector. So what is the function of detector? The eluted solute particles along with the carrier gas exit from the column and enter the detector. The detector then produces a electrical signal proportional to the concentration of component substance. The signals are amplified and recorded as a peaks at interval on the grid. So these are the function of detectors. Properties of an ideal detector. So ideal detector should be sensitive, operate at high temperature, stable, reproducible, linear response, wide dynamic range, fast response, simple, reliable, non-destructive, only for response. These are the different conditions. Thermal conductivity is based upon the fact that heat loss from the filament depends upon the thermal conductivity. The thermal conductivity. When carrier gas flows, heat loss of metal block is called filament remains. When an allied species flows past filament generate thermal conductivity. So these are the different conditions. So you can see the different spots will be given in gas. So what are the advantages and disadvantages of gas liquid chromatography? Simple, inexpensive, durable, possess a long life, accurate results, non-selective hence known as universal. These are low sensitivity effect, right? So electron capture detector molecules of compounds which possesses affinity for electron differ in the electron absorbing capacity. So a coil made of a radioactive metal like nickel is placed inside a Teflon coated cell. So these are the characteristics of electron capture detector. You can see. So these are the mechanism of the gas liquid chromatography. Radioactive substance will be detected cathode, non-eluted, high selectivity, highly sensitive for detection of compounds, being non-destructive, more sensitive, less sensitive to compounds whose molecules are negligible, carrier gas used to pure like pure nitrogen, flame analysis. So these are the different detectors are used in gas. So flame means this is one light will be given to this collector electron. Flame magnesium coil, flame photometric detector. So this you are. So let's see chromatography five component lesson. So in gas liquid chromatography, we have five different compounds. So we can see these peaks in a detector. Evaluation we can have application. So this is applied in qualitative analysis, also in quantitative analysis in different fields. So we can see chromatography and negligence is compound by other methods of calibration count. These are the depending pharmaceutical application. Quality control analysis of drug products like antibiotics, antiviral. We can use this gas chromatography. So analysis of food like carbohydrates, proteins, lipids. So these are the different in different fields with gas. So next we'll see another HPLC. These are the different chromatography you can see one by one. So next unit is the HPLC. So HPLC is nothing but high performance liquid chromatography. So this is a very high advanced liquid chromatography. So what are the instruments around this now? Let's discuss. A form of column chromatography to separate, identify, and quantify the compounds, developed in 1970. The most widely used analytical separation technique is in HPLC stands for high performance liquid chromatography, sometimes for high pressure liquid. High performance liquid chromatography HPLC is a powerful tool in analysis. It yields high performance, high speed compared to traditional columns chromatography because of the possible formed mobile phase. HPLC is a chromatography technique that can be separated mixture of compounds. So we have a mixture of compounds. Especially we can separate enantiomers. So in stereochemistry we know that HPLC is a chromatographic technique that can separate a mixture of components used in biochemistry. Am I audible? Yes.
Yeah.
Okay. So we are talking about HPLC. So HPLC is high performance liquid chromatography. So see, the all part is theory part. So you will read yourself that you have to give a short note type of questions. So what is chromatography? We will study gas chromatography, ion exchange chromatography, HPLC, thin layer chromatography, all the chromatography methods. That means separation of mixtures. This chapter includes only separation of mixtures. So this is completely theoretical part. So HPLC is a chromatography technique that will separate mixture of compounds. It is used in biochemistry, analytical chemistry to identify, quantify, purify the individual components. So chromatography, physical method in which separation of components takes place between two phases, stationary phase and mobile phase. So chromatography, we have two phase, stationary phase, mobile phase. Here, in stationary phase, always is the substance on which absorption of a analyte जो substance use करो separate during the chromatography takes place. It can be solid, can be gel, can solid liquid combination. Mobile phase, solvent which carries analyte. तो दुईटा phase था ଗୋଟେ stationary phase and mobile. So mobile phase always we have taken the solvent. So in HPLC, the extents of conventional equipment. So HPLC is nothing but extends advanced phenomenon of liquid chromatography. So this is a powerful tool in analytical techniques. Columns are tightly packed and the lubricant is forced through a column under high pressure. So different columns will be taken which have high pressure. So the solvent will pass through this thing. So allows to use a very smaller particle size for a column packing method which gives a much greater surface area for interaction between stationary phase and molecules both allows us much better separation of you can still say so these are the different characteristics of accuracy. Just a minute. So we have So what is the principle of SPLC? So you can see. So these are the principles on which SPLCs were constructed. So principal involved SPLC can be either adjacent or partition. Interaction of sample with both stationary phase and mobile. So sample can interact with both stationary phase and mobile phase. So the analyte are injected into the flow of mobile. Outlet of column is connected to a detector where the elutant substance are detected. The separation is achieved in a column packed with stationary phase material of low particle size. The reliable flow rate of mobile phase with the appropriate pressure is applied. The sample mixture is interacted between stationary phase and mobile. The interaction between these phases results in separation. So these are the simple principles. First, the sample will interact with stationary phase and mobile phase. Secondly, the analyte, the compound which we analyze, are injected into the flow of mobile. So, mobile phase in the mobile phase, the analyte will be injected. Outlet of column is connected to detector. So outlet is will be connected in a detector where elutant substance are decoded. So what will be removed from the system that will be detected in the detector. The separation is achieved in the column packed with stationary phase material of low particle size. The reliable flow rate of mobile phase with appropriate pressure is achieved. The sample mixture interacted between a stationary phase and mobile. So as a result, we can separate. When a mixture of components are introduced to the column, various chemical and physical interactions take place between the subcon and molecule. They travel according to their so you can see their affinity towards the stationary phase and component. Component which is less affinity towards the stationary travel first. The components which is less affinity towards the stationary travel faster and that will mutate faster. So in SPLC, we utilizes liquid mobile phase to separate the mixture. So mobile phase is a liquid, like liquid chromatography. In SPLC, the mobile phase is a liquid. Analyze that fast results, then put the column under high pressure. Total separation time is often 5 to 10 minutes. So within 5 to 10 minutes, the components will be separated in hours or even days. So what are the components are used? Instruments are combined in expense. So one is pump, another is a injector, another is a column, and another is a detector and recorder or data system. So these are the different components used in HPLC. So this is the flow scheme of HPLC instrumentation. So you can see the flow chart here. So here is the form. Sample will be emitted here, and this is HPLC. So this is the total process of HPLC. So you see this. This is the instrumental. So it's a in the first slide, we have given the PLC machine here. So here, different here we have a pump. Here, column box will be there. Here, injection valve is there. So we'll discuss one. So a pump forces the mobile phase through the column at a much greater velocity than gravity flow columns. The pump can be pneumatic, series type, reciprocating, or hydraulic pump. So a pump will be used in this SVLs. So pumps are designed in order to maintain a stable flow rate, avoiding pulsating leaving when compression of mobile. So flow range varies 0.01 to 10 ml per minute. So these are the different flow. So injectors inject the liquid sample. So another part is the inject site where liquid sample within the range of 0.1 to 100 ml of volume under height. So produces a minimum band broadening, produce possible source disturbance. The next thing, in SPLC machine, here you can inject your sample. So here the injector, model of injector. So if you see SPLC machine, here you can inject your sample. Very sophisticated machine. So you can see here. So this is a load position, load also injection position. So you can load this sample by using a syringe. So this is a very small size column and the passage is just a very column. So what are the columns used in this case? Smooth bore stainless steel of heavy white glass steel is used. So this is hundreds of wax columns differ in size and packing are available. Column packing varies size. So these are the different type of columns. So let's see how these columns looks like. So you can see these columns. So these are the different size columns used for different purposes. So you can see this column size vary depending upon the mixture. So this can be stainless and chiral column will be given here. So we can use chiral column for the separation of the ions. We can see. So you can these are the different parts of HPS. So this is column, as you see, this is the injector, as you see, this is the pump. So these are the different parts are combined assembled in the HPLC machine. So this you can see standard column hardware. So these are the different processes is given. The hardware means the column made out by using this switch. One this is inside the column packaging will be there, yeah, nut end fitting will be there. These are the manufacture of column. So let's see detector. How we detect the signal? In HPLC, the detector monitor the unit as it leaves the column. Produce an electronic signal proportional to concentration of each separator. Crucial in trace analysis, high sensitive, fast response, simplifies the quantization, insensitive to change in type of signal. So these are the detectors. The most widely used detection method. So what are the different methods used? Spectrophotometers, fluorometers, electrochemical detector, mass spectrometer, refractive index detector. So detectors used in what are the different detectors used in spectrophotometry, measurement of levels, detection limit. So these are the different detectors used and they are different comparative measurements. Mass spectrometer is so this is all about detectors used in space. Depending on the relative polarity of the solvent stationary phase, there are two variants used in space. Normal phase space utilize polar absorption surface non-polar emitted polar substance in the mixture sticks to polar absorption non-polar ones will pass more quickly. Reverse physics utilize nonpolar adsorption surface polar emitted attraction between nonpolar components. Reverse phase speeds. Polar molecules will travel through the column more quickly because there is a strong attraction between polar solvent and polar molecules. Reverse phase speeds is the most common used for reference. Solvent in what are the solvents we can use in the mobile phase of HVAC? So hexane, heptane, cyclohexane, CCl4, carbon tetrachloride, benzene, toluene, diethyl ethyl chloroform. So these are the different organic solvents used in the mobile phase in HVAC. Absorb. What are absorbent means specified phase? We can use silica gel, alumina, xylite, cellulose powder, iron exchange, cellulose starch. So these are used for the stationary phase. So retention time. What is the retention time? The time taken for a particular compound to travel through the column to the detector. So what is the retention time? The time taken for a particular compound to travel through the column to the ଯେତିକି ସମୟରେ ସେ କମ୍ପାଉଣ୍ଡଟା ଟ୍ରାଭେଲ୍ କଲା କଲମରୁ ଡିଟେକ୍ଟର that is called retention time. From the time at which the sample is injected to the point at which it displays shows the maximum peak height for that compound. So this is known as retention time. So you can see the retention time looks like. So in HPLC you will see the graph looks like. Types of chromatography. So how are the different absorption chromatography, animation cover, side absorption? Absorption chromatography composition of absorption sites across between the molecules mix. Ion exchange, so ion exchange, so these are the different. So in separate ion exchange will be used given. So in HPLC you can use this. Application HPLC is used for chemistry and biochemistry research analytic complexes, purifying chemical compounds, qualitatively controlled to ensure the purity of raw materials, analyzing air and water. So experience used for different purposes. So these are the application of HPLC. Monitoring materials that may geoportalize operation, monitoring the pesticides leaves in the environment, to survey food, drug products, to identify counterfeit narcotics, determine the amount of species is compared with classical technique. Small diameter, reusable stainless steel column plates with very small packets. So these are the different used for column. SPS is something that is very difficult to afford in a research background. So this is the complexity. So the instrumentation is very complexity. We need a maintenance in period of time. More sensitivity of some compound, irreversible, the compounds not detected, pollution difficult to detect.
Summary: a modern day technique is greatly enhanced in terms of selectivity, resolution, to miniaturization, and use of very elaborate systems. Therefore, SPLC is widely used for separation of molecules in biological, pharmaceutical, and food environmental industry. So these are the different technique for SPLC. So what is the SPLC? What is the different components are working in SPLC? What is the application of it? So this is one advanced technique of chromatography. So we see next slide, ion exchange. So next is very important, ion exchange chromatography. So let's say it is a process of separation or mixture of ions of similar charge ions using ion exchange. The process of separation of mixture of ions of similar charge ion means positive positive or negative negative charge ions will be there that can be stored on nickel to plus action. Incoming call from Baba Bahagram identified by Truecaller. Reversible action similar charge ions either cation or anion. Most of the pharmaceutical drugs and weak acid surface. Therefore, mixture of similar charge drugs can be types of ion exchange cationic exchange chromatography. Separation or mixture of cations using cation exchange method. So you can see types of ion exchange, cation exchange chromatography. So here separation of cation, separation of mixture of cation using cation exchange regime, which exchanges ion based on their relative cation exchange cation to which active counter-cation express status reverse reaction with each active cation. Anion exchange chromatography. 744. Thank you. Separation of mixture of anion using anion exchanger, which exchanges ion based on their relative affinity. Anion exchanger is a polymeric cation to which active counter anions are attached and reversible reaction in which these active anions are reacted with the other anions present in it. So we can separate anions by anion exchanger regime. We can separate cations by cation exchanger regimes. So we can separate cations by cation exchanger regimes. We can separate anions by anion exchanger regime. So separation of mixture of cations using cation exchanger. So cation exchanger can keep anions to active counter-cations are used. Similarly, anions can be separated by anion exchanger regime which exchange the ion by polymeric cation to which active counter anion are attached and processed. The principle of mechanism of ion exchange chromatography. Ion exchange chromatography principle. The principle involved in the technique is the reversible exchange of ions between ions present in sample and ion. So these are the different principles. So here only this technique is between ions present in sample. Consider the separation of cation. Suppose we are separating a cation using cation exchange. The cation exchange will attach to the cation will form a solid cation complex and H plus in the sum. So cation retained by the solid matrix of ion exchange resin can be eluted by using buffer different strength and separation. Anion exchange. Separation of anions using anion exchange resin can be carried. Anions to be separated are present in the solution. Exchanges for similar ions present in it. The exchange resin, a solid matrix exchange, can be represented by following: solid A minus solid cation O. The anions retained by the solid matrix of ion exchange resin can be eluted by using buffers difference. Hence separation, hence separation. So solid. So similarly, one ion exchanger, solid ion exchanger will attach to an ion to form a solid anion complex solution. The anions retained by the solid matrix of ion exchanger can be eluted by using buffer of liquid. Classification of ion exchanger: chemical nature, source from which they obtain. So these are the different classification classified in different nature of chemicals source which is obtained. So chemical and types of resins. So different resins we are found on the depending upon this chemical. So strong acidic cation resin, sulfolated polystyrene resin. These are ionosables, sulfate. So this can be acidic or alkaline nature. Weakly acidic cation, exchange resin, carboxylic polymer acrylate, alkaline. Strongly basic anion exchange resin, that is tertiary amine type, acidic alkaline. Weakly basic anion exchange alkaline. Based on source, cations are zeolites, clay, etc. Anions are dolomite. So organic mostly wide is organic ion exchange resin, polymeric resin matrix, anion exchange sites, composites of polystyrene. So these are the different resins used in ion exchange chromatography. So these are ion exchangers, organic ion exchange resin, that polymeric type exchange, polystyrene, etc. So this is available. So in ion exchange method, and separation of missions. So we can use a cation exchange chromatograph or anion exchange chromatography. So these are the so here in ion exchange chromatography method, we can separate ions from each ion exchange. So we can can see an iron exchange chromatography. In chromatography, an iron exchange chromatography, and an exchange, an iron exchange. So we'll see that this is about iron exchange chromatography. So these are the different. Most important. So whatever size, this is another type of chromatography, size exclusion chromatography. So this is another type of chromatography, is size exclusion chromatography. Just 1 minute, please. 1 minute. Right. How to? Right. Size exclusion chromatography, also called gel filtration, gel permeation chromatography, uses for porous particle to separate molecules of different size. So if we have a small size particles, we can separate by this size exclusion chromatography. It is generally used to separate biological molecules and to determine molecular weight and molecular weight of distribution of polymers. So it is usually applied to large molecules and macromolecule complexes such as proteins, industrial polymers, etc. When a aqueous solution is used to transport the sample through a column, the technique is known as gel filtration chromatography. When an organic solvent is used as a mobile phase, the technique is known as gel permeation chromatography. So the separation of molecule is called fractionation. Size of force is used to determine exclusion. So these are the different simple introduction about size exclusion. So what is the principle by which this chromatography works? A mixture of molecules dissolved in a liquid, the mobile phase is applied and chromatographic column which contains a solid support in the form of microscopic spheres, beads and stations. The mass of beads within the column is often referred to as a column. Crabs, sieves and function. Large molecules pass around are excluded from the base. Large sample molecules cannot or can only partially penetrate the pores, whereas smaller molecules can access most all pores. The large molecule eluted first, smaller molecule eluted. So here the simple larger molecule eluted first, smaller molecules eluted later. While molecules that can access all the pores eluted last from the particles of different size will elute filter to a stationary phase at different rates. So what is the principle? A mixture of molecules dissolved in liquid is applied to a chromatographic column which contains a solid support in the form of microfluidics. Research. The mass of bits within the column is often referred to as a column. The bits act as a trap and shifts function to filter small molecules will become temporary trap. The larger molecules pass around are excluded from the bits. Larger sample molecules cannot or can only partially penetrate the pores where small. So you can see, so in this way, this is the total demonstration of size exclusion chromatography. So you can see different size pores can separate it in different time. So we see this works upon the different so volume, total volume, column volume is equal to Vg, Vi, Vg, where Vg is the volume occupied by packing, Vi is the volume of solvent in pores, Vg is the free solvent molecules. So these are what are the components are present in size exclusion as discussed. Right? Secondary is the mobile obviously in a column we have two constant one is stationary phase, another is the mobile phase. So another is columns and the pump and detector. In all other cases, pumps, detector, column and mobile phase. So in stationary phase, we'll take semi-permeable porous beads. So what will take semi-permeable porous beads with with uh, porous beads with well-defined range of pore size. Beads are cross-linked polymers. Degree of cross-linking controlled carefully to a different pore size. Smaller pore size are used for rapid resetting proteins or protein purification. Intermediate pore size are used to separate exiting small. So these are the some characteristics of stationary phase. You retain size expression chromatography. So very large pore size are used for purification of biological complexes. Stationary phase used for gel exclusion chromatography include extern polyacrylamide, extern polyacrylamide. Size is available with a variety of different range of pore size in methods, permitting separation of macromolecules of different size. Good stationary phase should have following properties. So what are the good stationary phase characteristics? It should be chemically inert, it should be inexpensive, it should not react with component to be separated, it should not react with the lubricant, it should be colorless, uniform in size, and it should be mechanically stable. So these are the different characteristics of good stationary phase within site exclusion system. Soft gel dextran, polyacrylamide, semi-rigid, highly rigid. These are the unit stationary phase unit in this moment. What is dextran? A homopolysaccharides of glucose. So this is used for this chromatograph. It is prepared with various degree of cross-linking to control pore size. It is bought as a dry beads oil, water to added. Trade name is Surfadex, mainly used for separation of small peptides and globular proteins. So this is all about dextrans. So dextran is nothing but homopolysaccharides. Glucose residues is prepared with various degree of cross-linking to control force. It is got as a dry beds and beds swell with water. So these are the different range size of chain or size of adsorbent using polyacrylamide. The gels are prepared by cross-linked acrylamide with anion dimethyl. Prepare cross-linked acrylamide when anion and dimethyl base pore size is determine the degree of cross. Separation properties will be there. So these are polyacrylamide used in the stationary phase. So agarose is also used in